The next section is compound values, which are arrays and objects. So far, all of our variables have held only one item at once, right? So let's go use this example here. We don't need the comments here. Okay, let's go back to the first line. So x is 1, 2, 3, 4, 5. We're going to run it. So again, remember the red arrow is the next line we want to run. So we're going to run it. So when we finish running that line, and the next line is line 2, x is 1, 2, 4, 5, y is hello, z is true. So good so far? Okay, so now x is 42. When we put x is 42, it overrides the old value. And when we put x is Bob, it overrides the old value. So this seems like a fairly obvious point, but it's illustrated here is that x can only hold one thing at once, right? It can either be 1, 2, 3, 5, or 42, or Bob. It can't be all three at once. And while that's fine for simple programs, you might want to hold more than one thing in an x or in a variable, right? You might want a variable to hold on to multiple things at once. And you can't do that with the primitive types, the numbers and strings and booleans and so forth. You just can't do it. So in order to do that, we're going to use what's called compound types. So there's two main compound or collections types in JavaScript. There's an array, which you declare using the square brackets. So here's how you declare some arrays. So I'm going to clear this. So you can say const x is 1, 2, 3, 4, 5. This will make a constant variable x and assign it to an array that has 5 numbers in it. 1, 2, 3, 4, 5. There's 1, 2, 3, 4, 5 right here. Arrays are 0 index, so it starts at index 0, just like many other languages. And now x is actually a pointer that points to an array object. So it's very different than the older picture where x, referred to some value directly. You can also hold strings in your array. So this array is const x is hello world goodbye. I'm going to shrink this a bit. So x now points to an array with 3 things: the string hello, the string world, string bye. Goodbye. Arrays can hold values of multiple types. So this is our 1, 2, 3, 4, 5, 42 Bob example. So an array can hold a number, and then a string. There's no reason why it can't hold more than one type of thing. You may not want to do this because it may be confusing, but it's very possible to do it. So this is very much unlike, say, a statically typed language like Java, where you have to hold things of the same type, or I guess subtype in here. But here it doesn't really matter. Just arrays can hold anything. Okay, so hello world goodbye. How do you get the contents of the array? So you get the content using brackets. So you can grab out individual elements using brackets with numbers in them. So let's do this example. So remember, this is hello world goodbye. So there are 3 elements here. There's the 0th, the 1th, and the 2th, I guess. So you grab them out by just simply using the brackets and then assigning to them. Whoops, I'm just going to do one line at a time. Hello or goodbye. Now, x bracket 0 is the 0th thing, so that should be hello, and we're going to assign it to a constant y. So when we run this, notice how the constant y, the y is actually assigned to hello. It actually just grabs the value and just places it in there. x1 is world, so we're going to hit forward and run it. And so the variable z points to whatever x1 was, which is the value world, and then w goes to x2, which is goodbye. So we've actually created 3 variables, y, z, and w, to hold the contents of x0, x1, and x2 respectively. If we try to access x3, something bad might happen, right? So actually in JavaScript, it just gives you undefined. So an out-of-bounds access, there is no x3, right? There's only x0, x1, x2. There's no x3, but JavaScript doesn't give you an exception. It just says undefined. So error is actually an undefined value. So sometimes it gets kind of annoying, some of these JavaScript rules, but the best way to do is just to try it on the console and to handle the errors accordingly. Okay, that's arrays. You can also modify the contents using brackets. So let's do this. We're going to do hello world goodbye again. Okay. Const x is hello world goodbye. So let's run it. So now x is hello world goodbye. I'm going to shrink this a little bit so it fits on the screen. Okay, so now this line says x0 equals hello there. So I want to change the content of x0 from hello to the capital hello there. Now when I run this line, it actually changes. Notice how this now changes to hello there. I'm going to go back just to show you what is before, right? Look at this one right here. Goes from hello to hello there. Now, similarly, x1 goes to earthling. So I want x1 instead of world. I want to go to earthling. So I go forward again. World changes to earthling. So notice how I go back. World, earthlings. And then now I want to x push 3.1459. Push is a method on arrays that pushes a new value on the end. So I'm going to push a value of pi on the end. Now notice how there's hello there, earthlings, goodbye. When I push, there should be a third thing. So when I hit forward, I'm scrolling off the screen here, but there's a third thing, right? I pushed it on. Pop actually just pops off the final value. So when I go back, my screen's a little too small, sorry. When I hit forward again, it actually just pops it off. So push, pop. Okay, so now in the end, I have some modified array that's hello there, earthlings, goodbye. Now something might be weird because I've talked so much about consts and constants before, right? I was like, always use constants. It means that you can't modify something. But it's actually not true, right? Because in this case, x was declared as a const, but I could mess with the array all I wanted, right? I could just, change elements, push elements on, change it from hello world, goodbye to hello there, earthlings, right? Notice how it's just changing under my feet. Yet this x is a const. So what's up with that, right? So it turns out that const only protects this x from being reassigned to something else. It doesn't say anything about the thing that x refers to. So if your x is referring to something that you can change, like an array, the const doesn't protect you at all. What const protects you from is this. Whoops. Const protects you from, when I go forward, this is all legal. Const protects you from this. Const protects you from changing the x to something else with an equal sign. So the only thing you cannot do to const variables is to reassign it using an assignment statement, which is an equals to something else. So you can do everything you want to the thing that x refers to, but as soon as you say x equals something else, x equals 42 or x equals Bob, then JavaScript will give you an error. So that's what const protects you from. It protects you from equals assignment. It doesn't actually protect what's inside of the objects that you're referring to. Okay, so that solves the mystery of why you can modify things even when it's declared as const. So const is nice, but it doesn't cure all of your bugs, right? Okay, so again, this is what I said. Const means you cannot reassign, right? You cannot reassign x to something else, right? So I'm going to use another example here. Oops. So starting in the beginning. So const x equals hello world, goodbye. That's fine. Can I push something onto x? Sure, that's fine too, because x is still the same thing. Now when I try to assign x to another list or array, it'll say no. It'll say assignment to a constant variable because I just can't do an equals to this. How do I actually make this work? I actually can use a let, right? If I use a let, then everything works just fine. First, I have x be hello world, goodbye. Then I push the 3.1459, see it here. And then when I say x is 1, 2, 3, 4, 5, it'll actually reassign x to a new thing called 1, 2, 3, 4, 5. The old one actually disappears, but we're okay. So let will let us reassign. Okay. So what does the equals mean for arrays versus for primitive values? So now we're going to get into a little bit more of the details of equals. So let's go back to the beginning here. So we're going to do const x is hello world, goodbye. This font's a little big. I'm just going to make it a little smaller so we can fit more on here. Yeah, there we go. Yeah, this is better. Okay, now when I say const y equals x, what does that actually mean? Does that mean that I'm making a copy of x and putting in y? No, actually, const y equals x means that y and x now refer to the same array. So remember that equals never copies arrays or objects. It just copies the values of the pointer. So it basically copies the values of pointers. So they both point the same thing. So now when I say that x0 is hello there, notice how this x0 will change to hello there. changes. Now the question is, when I say y0 and I console log it, what does it print out? Well, there's only one thing to print out at y0, which is hello there. There's only one thing, which is called hello there. So if you look at the diagram, it's pretty clear what it is. It's hello there. But if you don't have a diagram, you might think that y is a copy of x, so that y might still be, the original y0 value might still be hello. But in fact, the equal sign in JavaScript, like in many languages, does not copy objects or arrays. It only copies the references to them. So this is this is another way to think about this. So if we made x and y, hello world goodbye, but we created separate objects. We didn't do a y equals x. We said x is hello world goodbye. Y is also hello world goodbye. To the outside world, they look identical, but they're actually now two arrays in memory. So now, because there are two separate arrays in memory, when I said x0 to hello there, now y0 has not changed, right? y0 is still hello. So when I console log, I'll still see hello. So that's the difference between doing this, which I'm creating two separate arrays, completely separate. They just happen to have the same value, but they're separate arrays. And this, which is when I do y equals x. If I do that, notice when I say const y equals x, x and y actually point to only one array. And when there's only one array and I set that 0th element to hello there, when I do y0, it's going to be hello there because there's only one array. So really pay attention to the equals and what happens with arrays. Okay, so there's another subtle thing that happens is that, what happens when I do this, right? What happens when I have primitive values? When I say const x equals hello, when I say const y equals x, it looks like it's just copying the value of x into the value, into the y slot, and both of those are copies of hello. But then I can also go like this and just define hello completely separately, and it still looks like there's a copy. So it's like, because this is a primitive value, it doesn't actually matter whether we're assigning it through something or we're making a copy, because these primitive values are what's called immutable. You can't change them anyway. So as far as your behavior of your program is concerned, it's as though they were two separate things, hello and hello. Even though in memory, in some implementations, these two hellos might actually only take up one spot in memory as an optimization. But for your perspective as a learner, you can imagine x and y just holding separate copies of that hello. And it doesn't actually matter because there's no way you can modify them individually. Whereas again, I'm just gonna really hammer home this point. If I make an array ABC and I have y equals x, they will both point to the same array. So what you can think of it is that this memory address it's storing is being copied from x to y. And these memory addresses both refer to this object right here because these both store, say, a pointer or a memory address. Okay. The distinction matters for arrays as well. So this is an example we already went over with the y equals x versus declaring x and y to be separate arrays that happen to have the same value, right? They look completely different. I just want to show you again. So this is the case that we just had, hello world goodbye. They both point to one thing, and this is the other case where they are both independent copies of hello world goodbye, right? And they can be modified separately. These mean different things. So basically, long story short, the equals does not mean copying. Does not mean copying, making a copy of the array. Okay, so how do we iterate through items, elements of the array? The Google style guide suggests what's called a for of loop, which is one of the modern for loops in JavaScript. So what you can do is, let's just declare this again. The hello world goodbye array, our favorite. So what you can say is you can say for const e of x, console.log. What do we say? Element plus e. Okay, great. So what this does is that it first declares x is hello world goodbye. The visualizer doesn't do a great job inside of here, but basically every time you go inside of here, an e variable will be declared inside the block. Remember that the for loop uses the braces to create a new local block. E will be declared inside of here. You're going to iterate through x every time you iterate through, one of the elements will be assigned to this E, and we're going to print out the capital element and then add E to it, and we're just going to print out. So the first time through this loop, E is hello. There's two E's here. It's the visualizer has a glitch, but ignore this undefined E. But basically, this is the E that you want to see. You want to see hello, which is the first element, and then we're going to print out element : hello. And the second time through, E is world. So we're going to print element world. And the third time through, E is goodbye, and we're going to print element goodbye. And then we're done. Once we're done with the loop, notice how it cleans up really nicely because this const E only exists inside the block defined for the for loop. So when we're out, there's only X left. And we've basically iterated through 3 elements of this array, assigned each one to E, and done something with E. This is like writing a for loop, except you don't have to like explicitly, find the size of the array and do an index and worry about off by 1 errors and stuff. So for of loops are pretty convenient.